My name is Keith Rucker, and today I'm standing in front of my Wells Index Model 847 vertical milling machine, and I want to take a little bit of time and shoot a little video today on how to do a pretty basic maintenance operation on this machine that, quite frankly, a lot of people just either don't know how to do or don't take the time to do on these machines, and that is how to tighten up the gibs or the ways on this machine so that you can take a lot of the slop out of the travel in the three axes that this machine can move in. I have owned this machine here, this particular milling machine, now for probably about 2.5 years, I guess. And to be totally honest with you guys, until just the other week, I had not done this machine. I brought it into the shop, I set this machine up, and I started using it. And it's been a very good milling machine, but one of the complaints that I've had with it is, particularly when doing heavier milling operations, I was getting some movement in my tables that was resulting in some pretty bad finishes. For most operations I was doing, it wasn't an issue, but again, when I was doing some pretty heavy milling, it could be a problem. And it seems like anytime you got a job going on, it's almost like, well, I just don't have time to do this right now. I just need to get this job done. And when I have some downtime, I'll get back and I'll get this done. I'll fix this machine the way it needs to be done. Well, long story short, I ended up going 2.5 years without doing this myself. So, but a couple of weeks ago, I was getting ready to do a job. I knew I was going to run this problem. I said, I'm going to take the time to do this. I did it, and wow, what a difference a little bit of time can make in the performance of this machine. Quite honestly, I have already done a lot of these adjustments to this machine, but after I did that, I said, this would make a good video for YouTube. I know a lot of other people might be able to benefit from this, so I'm going to go over now how exactly you go about tightening up the gibs on this particular machine. Again, this is a Wells Index Model 847 vertical milling machine. However, the procedure will be very similar on other milling machines. I know from experience working with old Bridgeport mills, as well as looking in some of the manuals, the procedure is very similar to this. Not exactly like this, but very similar to this. But I think you should be able to get a good idea from this video on how you can tighten your machine up. Before we get very deep into this process, I want to make sure you understand what we're talking about with ways and gibs. This is the saddle way on this milling machine that is going to move the table in and out from the machine. And if you look, there's a dovetail here. This is a 60-degree dovetail, and there's one on both sides. And up in here, you really can't see it because there's a cover covering it up. You have a more or less a matching dovetail that will allow this to slide on there. But there is what's called a gib that will fit in between this casting here and this casting here, and that's usually either a cast iron or sometimes a steel plate that takes up the slack in here, and it also is adjustable so that you can tighten that up. And what happens over time on these milling machines is, as you use them, you get some wear, or it just may become out of adjustment over time, and this gib will get loose in here. In this particular machine, this gib is tapered from one end to the other, so it has this matching angle here, but the thickness of the gib will actually get thinner as it goes from one end to the other. And the way that you tighten this up is there's some set screws that will adjust in on a wedge that will tighten up or loosen, if need be, that gib that goes along this surface here. And by tightening that up, you can take that slack or that slop that's in this machine out. That is assuming that the wear is even across the length of the dovetail. And in most cases it is fairly even. In some cases where you may have an older machine that was used in a production situation where it really was only used in a small amount of travel, you may not always get even wear, but generally speaking, in most cases, you will see fairly even wear on these, and they can be fairly easily adjusted by just simply tightening the gib. I also want to mention the procedure that I'm using to adjust this and also to check the different tables and the different axes on this lathe or this mill to see if they're within specifications is not a procedure that I invented. In fact, I got this procedure right out of the manual on this machine. So always refer to the manual on your machine for how to do this. Most of your better machines, you can have a manual for, they're going to tell you exactly the procedure to use. As to finding a manual, if you don't have a manual, I would encourage you to go to our website, vintagemachinery.org. And on that website, we have publication reprints on literally thousands of publications that have been archived on our website that you can go to and download for free. Old manuals, catalogs, etc., documenting these machines. The manual for this machine is on the vintagemachinery.org website, and you can actually just go there, download it, print it out, look at it on your computer however you want to. Again, absolutely free. While we're talking about the vintagemachinery.org website, I would also say that if you're looking at these videos, you're a machinist, or you have some manuals or documentation on old machines in your library that you would like to share and make available to others, we allow people to upload scans of these publications to share with other people. We do not charge for this. There's no cost for doing it. It's completely voluntary, but it's something that I think helps a lot of people out by making old information readily available. So I encourage you, if you have any old documents, to scan them and submit them to the vintagemachinery.org website so that other people can benefit from the information that's in there. Before we go any farther on actually showing you how to adjust the gibs, the first thing I want to do is show you how to check the tables on your mill to see whether they need adjusting or not. This is also a very important step, and one that quite honestly most people just don't know how to do. And again, it was right out of the manual on how to do this, and I'm going to show you a couple of quick places that you can check these measurements and tell whether your milling machine needs adjustment or not. The first position that we're going to check on this milling machine will be to check the table gib. Okay, the table gib is a gib that's going to be mounted up under the table. There's again a dovetail way that crosses back and forth in here. You really can't see it from here, but it's up under this table, and it's going to be the table or the gib that adjusts the table that's going to be moving in this direction. What we want to do is see if that gib is tight, and the way we do that is to put a dial indicator onto the machine like you see right here, and notice that we have it mounted to the casting above the saddle of the table here, so it's on the actual casting here, so we're not checking any tolerances that may be out in any of the other gibs, only this one gib here. So I have it mounted right here, I have my indicator over here, and I also have the table extended out pretty far, and the reason is I want to be able to get some leverage and just simply shake the table back and forth, in and out, push it in and out. Like I'm doing right here. And if the gib is tight, you will notice that there is no movement on the dial indicator. If the gib is out of adjustment, what you will notice is that you'll get some movement on there. How much movement is okay? Again, according to the manual that came with this machine, it says anything up to 1.5 thousandths is within tolerance, but it should always be less than 1.5 thousandths. And whenever you move the table in one way or the other, the table should snap back to 0. So as long as your table is okay there, everything is good. We've checked the tolerances of the table gib, and as you should have been able to see in the video, it looks very good. I was hardly able to notice any deflection on there in this axis whatsoever, which is exactly what I want. We want the gib to be tight enough that we're basically removing all of the deflection, but yet loose enough that you can still crank it and move it without any great amount of resistance. If it's too tight, you're just going to cause it to wear faster, and if it's too loose, you'll have movement and play in there which can interfere with you. If we did need to tighten this gib up, it's a fairly simple procedure. On this milling machine, there are two adjustment screws, actually one adjustment screw and one lock screw. On the table, on this Wells Index machine, the lock screw is on the right hand side. There's an Allen wrench that'll fit, or an Allen set screw that in there that you take an Allen wrench and put on it, and you loosen the lock screw, and then there's another hole on this side of the table where you again put it in there, put the set screw or the wrench in, the hex wrench into, and you can tighten the gib by tightening that up. And then once you tighten it up, you then tighten up the other screw, which will hold it in place. On some mills, I think the Bridgeport mills are this way, there's only one screw, and that's an adjustment screw. There's not a lock screw. On this Wells Index mill, again, there's a lock screw and an adjustment screw, but on many mills there will only be an adjustment screw. That's one adjustment down. Now we're going to move on to looking at the saddle gib that will adjust the table in and out from the machine, which will be the gib that's located right here. To do that, what we're going to do is we're going to move the indicator. Again, on the first one, we made sure that the indicator was mounted to the casting that was above the saddle gib. In this case, we're going to actually put the indicator on the saddle itself, just moving it down, so that we are actually going to be looking at any deflection between this casting and this casting. With the indicator mounted on the saddle and the indicator pointing to the table, again we're going to come over here to the end of the table that is extended out so that I have some leverage, and we're going to pull it in and out, pushing on it and pulling on it, and see if there's any deflection in that axis. As with the table gib, the tolerance on the saddle gib is going to be 1.5 thousandths. And as you can see, I am getting a little bit of movement on this one. It's not quite as tight as the table gib was, but still it's probably only about 1/4 thousandth, well within the 1.5 thousandth tolerance that we have. So I'm just going to leave it like it is. I'm happy with that, and we'll move on to the next measurement. For the saddle, if it needs adjusting, the adjustment screws are on the left hand side, and you see the small hole. This is the one in the front. There's an identical one on the back side of the machine. The lock screw is on the rear of the machine. The adjustment screw is on the front of the machine. So you should loosen the lock screw, tighten this screw here, again just using an Allen wrench, and then once you have it adjusted, you tighten the lock screw in the rear of the machine once again. Again, because this one was within tolerance, I'm not going to be adjusting it. The next measurement of the check will be for the knee gib, and the knee gib will fit into this dovetail right here on the left hand side of the machine, and the knee dovetail or knee gib will be to tighten the Z-axis, or the up and down axis, where you raise and lower the table. What I've done is I've mounted my dial indicator onto the base of the actual knee, and I have put it against the machine itself. And what I will do is I will just pick up on the front of the table and look for any movement or in and out. And as you can see, we are getting some movement here. And I will have to admit to you that I loosened this gib up because I wanted you to see this, because in my situation, this is the axis that was out of adjustment on my mill. It was the Z-axis, or the knee gib, and it needed to be tightened up. So you see that we're 5 thousandths there, well out of tolerance. The tolerance on the Z-axis here on the knee gib is actually 3/10,000ths of an inch. So this is the most critical of all of them that we will measure today, 3/10,000ths. So we're going to need to tighten this one up. To adjust the knee gib on this machine, just like in the other, there's a lock screw and an adjustment screw. The lock screw on this Wells Index mill will be on the bottom of the gib, whereas the adjustment screw will be on the top. Also notice that there's a nice little cap here. Just take a screwdriver and you can pry that off. In reality, all of these access ports should have a cap on them. Some of mine are missing, but I have most of them on there. But you can see I just removed that off, and the set screw will just fit down in here. So the first thing we're going to do, though, is go up under the mill. We'll loosen the tightening screw, and then we'll adjust the screw up here, and again check it for deflection. Okay, that's loosened. I'm going to move this out of the way. That's starting to get tight now. Put the indicator back in place. And we'll check it again for deflection. Okay, I'm still getting about 0.02 of an inch of deflection, so we're going to tighten that up a little bit more. Okay, I've tightened the top screw. I've also tightened the locking screw on the bottom now. We're going to check it one more time for deflection. Zoom in here where you can see that. All right, I'm putting a good bit of pressure on here. And the needle is moving just ever so slightly, but that's only about 1/4 of a thousandth. That's going to be very close to the 3/10,000ths that we need for our tolerance. So I'm going to leave it there, and we're going to go with that. I think we've made a major improvement to our milling machine by making this adjustment. We've now got all 3 of the gibs checked out, but yet there's one more final measurement that we need to make, and that is to make sure that the table is actually running parallel to the head itself. So as you can see, I've got an indicator set up here mounted to the head and going down to the table. And what we'll do now is we're just going to run the table the full length, and we're going to check to see if there's any run out over the length of the table. Again, according to the manual, the tolerance on this is 1.5 thousandths of an inch over the entire length of the table. Okay, we're going to use the power feed on this to make this a little bit easier. I have the table all the way over to the left, and now what I'm going to do is move the table all the way to the right, and we'll measure the total amount of run out over the length of this table. And that was the final test. As the indicator was moving across, you probably noticed that it moved about 1/1000th out as it got toward the center of the table, and then came back to 0 toward the other end. And what that indicates is that there is some wear in the gib on the table, in the center of the table. And on an older mill, you would expect that, because that's where most of the travel is taking place. However, the run out was still only about 1/1000th of an inch. According to our book, we have 1/1000th, so I think we're still within tolerance on this machine. If you do run into a situation where that is not, if it's running a little bit out of tolerance, what you can do is again adjust that table gib a little bit more to try to get it just set just right. And you can also sometimes take a little bit of that out by tightening up the saddle gib as well, because what happens is as that table goes to one or the other, you get weight on the end of the table that's deflecting the entire table one way or the other, and sometimes that little bit of deflection, maybe 1/2 thousand, so you can take out in the saddle gib as well. So and if you do have to make any further adjustments, I would encourage you to put your indicator back on in those positions and check that as we did earlier. So 4 measurements, 3 adjustments, and you can pretty well easily adjust the gibs or the ways on this Wells Index milling machine and get it running much better. Going back to my experience, why it took me almost 2 years to do this on this, I have no excuse. It's really a pretty easy adjustment. It's something that anybody can do their mill in just a little bit of time. Doesn't require really any special tools other than a good dial indicator, which most machine shops or machinists are going to have anyway, and an Allen wrench. And again, the procedure for this Wells Index mill will be very similar to other mills that are out there. I'd encourage you to just go look at your manual for your machine, and if you don't have a manual for your machine, again, check out vintagemachinery.org and see if you can find a manual there. We don't have them all, but we have quite a few manuals for a lot of different metalworking as well as woodworking machines. So go give it a look and see what you can find. And if you have any manuals for your machine and you'd like to share with other people, feel free to scan that and upload it to the site. We do not charge anything for our services on vintagemachinery.org. It's just a service to the people that are out there using these machines and trying to make a living, or either as a hobbyist to play around with these old machines. So that's it for today. We'll see y'all later.